Hello everyone, my name is Jay1. Very excited to be here to present our work DiffusionDB, a large-scale text-to-image prompt gallery dataset. So in last year, we have seen a breakthrough of text-to-image generative models. So there are multiple models such as DALL-E 2, Stable Diffusion, and Midjourney. Those models can generate images by using a text prompt input. For example, given a sentence, a photograph of an astronaut riding a horse, this model will generate realistic-looking images. Like we can see really a photograph of an astronaut riding a horse in those images. In particular, Stable Diffusion, as the first open-source large-scale image generative model, has attracted a lot of users. Like more than millions of users have tried out using Stable Diffusion to generate billions of images. Those are the images ranging from realistic-looking photographs to artistic work, so 3D model rendering. And despite the impressive quality of most of images, we can also notice there is some obvious mistakes the model is trying to make during the image generation process. For example, there are more than 5 fingers in one hand. And because those models are very nascent, so many people have a need for analyzing or studying the existing prompts and images to see how people use those images in real life. For example, AI researchers can use it to study how people use those models to see what the model's weakness, so they can try to improve the model by collecting more training data. For end users, they can also look at how other people write their prompts to learn how to write a good prompt so they can generate the images they want. And for human-computer interaction researchers, they also want to see how to write good prompts, so they can help user building tools interface to help user write good prompts. And for policymakers, because the technology is still very nascent, so people want to use to analyze the existing prompt images to see the possible misuse, so they can introduce policies to regulate the use of generative models. And for security researchers, they can also use to see the images generated by users to see maybe train a model to detect deepfakes to classify the real images or the images generated by AI models. And despite the desire needs, there currently no existing dataset having the real prompts for the text-to-image generative models. And to tackle this challenge, we introduced DiffusionDB, the first open-source large-scale text-to-image prompt dataset. So we have 14 million image prompt pairs. For each pair, we have the prompts, hyperparameters, people use generated models, and also generated images. And all those prompts and images are collected from real stable diffusion users. To collect a dataset, we script messages from Discord. So Discord is a messaging app where a user can use a special bot called DreamBot to generate images using Stable Diffusion. So for example, here's a screenshot of a user using the DreamBot to generate images. So we download all the images, and then we script the timestamp, username, prompt parameters, generate images, and the random seeds from those messages. And we script all messages posted in August 2022. By collecting all the information, we put them together, so we have a DiffusionDB with 14 million image prompt pairs. For each pair, we have an image, the prompt, and also the metadata, such as the user's name to protect privacy. Also use hash to encode the username, and also the hyperparameters to generate those images. It totals 6.5 terabytes for the whole size for the DiffusionDB dataset. And also notice there is some unsafe content in DiffusionDB to help future users to filter out those unsafe images. We also use a state-of-the-art pre-trained model to detect NSFW content. So for prompt, we use a toxicity classifier to detect the NSFW scores. And for images, we use also a pre-trained unsafe image classifier to detect the images with sexual content, also some violence content. And for each sample, so we have so we compute the probability score of having an SW score for each sample, and we associate each sample with 2 scores, and we distribute them with the DiffusionDB. Then we publish DiffusionDB on Hugging Face datasets, so where user can easily browse to see the different images examples, and also very easy to use the DiffusionDB in their different workflows. We also introduce a modular file structure, so user can download different simple sizes, different slices, or different subsets of DiffusionDB, but DiffusionDB is very large. We also use different formatting to help user use such as lossless WebP images to encode images, also Parquet to encode the tables. We also distribute DiffusionDB using CC0 license, which is Creative Commons, so people can do anything with DiffusionDB. And also, after having DiffusionDB, we also try to analyze the different properties of the prompt and also images. For prompts, we look at length of different tokens. We notice that most of the prompts have the shorter tokens, but about 10 is the peak of the number of tokens. But also their long tail distribution. To learn more about prompt distribution, please check out our paper. We also studied the composition of different prompts, so we introduced a circle pattern visualization to see what some popular phrases. For example, here we can see how users use different categories under painting, such as painting, oil painting, realistic oil painting, matte oil painting, to highlight and guide users to generate the artistic style they want. You can also visit the link in the slides to try out the tool in your browser. We also study the prompt image alignments by using the clip embeddings. So we generate clip embedding for the prompts of the images, so same prompt for the same images, and then we put them together. We visualize them in 2D space, and we see how they differ. You can also visit the link in the slides to see the tool in your browser. And here's a quick summary. So we've noted that the two distributions do not really overlap perfectly. So we should also highlight there is some points like the Stable Diffusion model cannot really generate images that perfectly align with the prompts in the clip embeddings. We also do some error analysis by looking at the spaces where the prompts and images are not well aligned. You can check our paper to learn more. And for future research directions, we think DiffusionDB is a very valuable asset. For example, researchers can use DiffusionDB to introduce design and develop tools to help users to engineer their prompts, generate images. For example, this image is generating the prompt using Stable Diffusion. People can also use images in DiffusionDB to see at which area or kind of images Stable Diffusion is not good at, so you can collect more training data to improve their models. So you can enhance their models by looking at the weak points of the current models. And also, security researchers can also use DiffusionDB as like synthetic dataset to train a better classifier to detect like deepfakes, so you can use them to detect generated images from the real images. And that's the end of my talk. So you can try out DiffusionDB by visiting the link in the slides. And to learn more details, please check out our paper. Thank you so much.